Welcome to 501 Matley, where we work smart, not hard. In today's problem, we're given this grid, and we're to determine four numbers that we're going to find the sum of in the following manner. We first pick a number at random. So let's say I pick an 8. Then I'm going to eliminate all the numbers that share that row and that column with the 8. Then, from the numbers that remain, I'm going to repeat the process. So let's say I pick a 2, then I'm going to eliminate the column and the numbers that are in the same row. And then let's say after that I pick a 15, I'm also going to eliminate that column and the row that it is in. And then finally, the only number that is left is the 9. So after all those numbers are picked, then the next thing is to see what is the sum of the four numbers that were picked. So here we'll have 9 plus 2 plus 15 plus 8 gives us 34. Pause the video here, pick any four numbers that you want following the same algorithm, and let's see what total you get. Well, believe it or not, no matter which four numbers are chosen, the total is always 34. And we're going to prove why in this video. So let's see. First thing we want to notice is that no two numbers are in the same row or the same column. Why is that? Well, let's see. If we were to pick the numbers in a systematic way, we can show why no two numbers are in the same row or the same column. To start off with, we have 4 rows and 4 columns to choose from. After we choose the first one, then that eliminates 1 row and 1 column. So that leaves only 3 choices for rows and column left. When we pick the second one, that's going to eliminate another row and another column, which leaves us with 2 rows and columns to choose from. So when the third number is picked, that eliminates another row and another column, and that reduces our choice to only 1 row and 1 column. Or in other words, there is no choice for the fourth number. So as we can see here, each number has to be in a different row and a different column from every other number. So we will keep that fact when we prove our result. Let's start off by writing these numbers instead of 1, 2, 3, 4 all the way up to 16 as 1 plus 0, 2 plus 0, 3 plus 0, 4 plus 0. In a little while, you'll see why. The next row, instead of that being 5, 6, 7, 8, I'll write it as 1 plus 4, 2 plus 4, and so on and so forth. The third row, instead of being 9, 10, 11, and 12, those are going to be 1 plus 8, 2 plus 8, and so on and so forth. And similarly for the final row, it's going to be 1 plus 12, and so on and so forth. Now, since we know that no two numbers are in the same row or the same column, basically that means that whenever we pick our four numbers, the four numbers are going to be in the 4 columns as well as the 4 rows. So when we pick our 4 numbers, we're going to get a portion of our sum from the 4 columns. What do these 4 columns have in common? The 1s, the 2s, the 3s, and the 4s. So that means our 4 numbers that we pick are going to have a 1, a 2, a 3, and a 4 as part of the totals. Also at the same time, the 4 numbers are going to be in 4 different rows. So when we pick those, there is going to be a portion that produces a 0, a 4, an 8, and a 12. So that's going to be adding up to our sum as well. When we add 1, 2, 3, 4, 0, 4, 8, and 12, that adds up to 34. No matter which 4 rows and columns the numbers are from, it will always add up to 34 because of those sums. Did you get it right? Were you able to prove that? If you found this video useful, please go ahead, hit that like button, share with others, and subscribe if you're new here.